Hey guys, welcome back to the channel. So this is the continuation video for the question paper that we were solving. The mains question paper. So the coaching institute is given and the paper is held very recently. So in this episode, we are going to solve all these 5 numerical type questions. Alright. So the goal is to show you problem solving strategies for JEE mains. Alright. So this question paper is slightly difficult than your actual JEE mains question paper. So if you are able to score good in these kind of question papers, you will get a really good marks in your actual paper. Alright. And also what we are going to do in this video is we are going to solve conventional problems in conventional ways, but wherever possible, from exam point of view, we are going to exploit the weakness of the questions as well. Alright. So the ultimate aim is to not do PhD on these questions. The aim is to get some marks. So whenever a question is weakly framed, we will exploit the weakness of the question. Alright. Okay. So let us start with the first question. The sum of squares of all values of x satisfying the equation. Alright. So we have to find the sum of the squares of all the values satisfying the equation. Okay, first log of, so logarithms is a very important concept for both your mains and advanced. All right, so spend some time on learning all the ways to solve these logarithm questions because this will help you a lot. All right, so let us say this is t. Then we can write log 8 of x square plus 7 is equals to 3 to the power 3 by 4 whole power t. Alright. Now similarly let us consider this. So log of 1 by 2 log of 1 by 4 x square plus 7 whole inverse can be written as 1 by x square plus 7. Let us say this is p. So now log 1 by 4 1 by x square plus 7 can be written as 1 by 2 whole power p. Alright. Now what we have to do is we'll do something. Alright. So this can be written as log of x square plus 7 divided by log 8 is equal to 3 by 4 whole power t. And here you can write log of 1 by x square plus 7 divided by log of 1 by 4 is equals to 1 by 2 whole power p. Now, so this is simply minus log x square plus 7 divided by minus log 4 on the left hand side. So this and this will get cancelled. So this is 1 by 2 whole power p. Now if you see, this is log x square plus 7. Alright, this is log x square plus 7. This is also log x square plus 7. So let us equate those two. Alright, log x square plus 7. Okay, so log x square plus 7 from here is 1 by 2 whole power p multiplied by log 4. So this is equals to log 8 multiplied by this thing, log 8 multiplied by 3 by 4 whole power t. Alright, now what do we have to find out? We have to find out t plus p is equals to minus 2. Okay, it is given in the question that, so this is t, this is p, so t plus p is equals to minus 2. So t can be written as minus 2 minus p. So 1 by 2 whole power p log 4 is equal to log 8 3 by 4 whole power t can be written as minus p minus 2. Alright, we have this particular thing right here. Now what can we do is 1 by 2 whole power p can be written as 1 by 2 power p So log 4 can be written as log 2 square. So that is simply 2 log 2 is equal to log 8 can be written as log 2 cube. So that is simply 3 log 2. This is equals to multiplied by 3 power minus p minus 2 divided by 4 power minus p minus 2. So 4 can be written as 2 square. 2 power minus 2p minus 4. Alright, this is what we got. This log 2 will get cancelled. Alright. So now 2 by 2 power p on the left hand side is equals to, on the right hand side, 3 minus p minus 2. Here there is 1 3. So this is minus p minus 1 by 2 power minus 2p minus 4. So cross multiply 2 power minus 2p minus 4. Here there is 1 2. So that will be plus 1. Here there is a p. So that is minus p. That is equal to 3 power minus p minus 1. So 2 power minus 3p minus 3 is equals to 3 power minus p minus 1. Alright. So this is 8 power minus p minus 1 is equal to 3 power minus p minus 1. So when will 8 power something is equal to 3 power something? So when will this happen? This happens only when the powers are 0. So minus p minus 1 is equal to 0. Therefore p is equals to minus 1. So our p is minus 1. So if p is minus 1, this is minus 1. So when this goes to that side, this goes to plus 1. So your t will also be minus 1. T is also minus 1. So your t is minus 1. Alright. Then from this you will get log of x square plus 7 base 8 is equals to 3 by 4 whole power minus 1. So that will be 4 by 3. Okay. So x square plus 7 is equals to 8 power 4 by 3. Okay. So 8 can be written as 2 cube whole power 4 by 3. 3 and 3 gets cancelled. 2 power 4 is 16. And when this 7 comes to this side, x square will be 9. X is equals to plus or minus 3. So we got two values of x. Alright. So therefore sum of squares of all values of x. So then that will be 3 square plus minus 3 square. So that is simply 18. So 18 will be your answer. I hope you understood how to solve this question. So these kind of questions appear in the integer section and numerical value sections of your JEE Advanced exam as well. So spend some time on logarithms and you'll be able to get an easy 3 or 4 marks. All right. So now let's go to this question. So this looks something like distance formula. All right. So this is your y2, this is your y1, sorry, this is your y1, so this is your x2, this is your x1. So x1 y1 is 4 comma 3, x2 y2 is x comma square root of 6x minus x square minus 5. So if you consider this, y is equals to square root of 6x minus x square minus 5. When you square it on both sides, you'll get x square plus y square minus 6x plus 5 is equal to 0. So this is basically a circle with center 3 comma 0 and radius 2. All right. So let us draw the circle. So this is 3 comma 0. This is 5 comma 0. This is 1 comma 0 since we know the radius. So to be specific, since it is given only positive value of square root, you have to take only the upper semicircle. All right. But when you do that, you will not get a numerical value, good numerical value. All right. But keep it in mind, if only the positive value is given for this, you have to take only upper circle. But in this question, I think to get a proper value for your m square minus m square, you have to take both the semicircles, upper semicircle and lower semicircle. You can try it with only upper semicircle and see how nasty your answer will be. All right. So okay, fine. So your 4 comma 3, this point lies somewhere here. So now if you draw a line like this passing through the center, your shortest distance will be this particular red distance, and your longest distance between these two curve, that point in this curve, will be this total yellow distance. All right. So let us say this is A, this point is B, this point is C, and this point is D. All right. Now we know AB is equal to 2, since that is radius. We can find out AC using distance formula. So that is simply root of 10. Therefore BC, which is your shortest distance, so that will be root 10 minus 2. All right. Now you can find CD as well. CD is equals to BC is root 10 minus 2 and BD is 4 diameter. So this is simply root 10 plus 2. So this is the greatest distance. So only when you consider the complete circle, you will get values like this. All right, root 10 plus 2 and root 10 minus 2, and that will make your simplification easy. Otherwise, strictly speaking, you have to consider only upper circle here. Okay. Now capital M is the square of distance, root 10. Okay, fine. All right. We have to find out m square minus m square. So that is simply m plus m. All right. Now what is m? M is the maximum value of this. What is the maximum value? It is not the distance, it is square of distance. So your m is square of this. All right. All right. Your m is square of this. Let us find out what m is. So your m is, when you square it, you'll get 10 plus 4 root 10. So this is 14 plus 4 root 10. And your small m will be square of this. Small m will be 14 minus 4 root 10. All right. So 14 plus 4 root 10 plus 14 minus 4 root 10. So that will give you 28 in the first bracket. So this is 28. Next, this is 14 plus 4 root 10 minus 14 minus 4 root 10. All right. Then you will get 8 root 10. So this is 8 root 10. So whatever value you get, so that you have to put here. All right. I am not sure whether I have done correct simplification. Maybe some calculations must have been wrong, but I just wanted to show you the method. Okay. And also, if you consider only upper semicircle here, then shortest distance will still be this distance, but longest distance will be this distance. All right. I hope you got to learn something from this. All right. Now let us move ahead. Maybe my calculations might have been wrong, but the approach is this is the approach. But this is the approach you should use. All right. Next, let's deal with this question. 23rd question. So f of x is this. F of x is 30 minus 2x minus x cube. And fn of x is f of x for n times. Then the number of positive integral values of f of 2000x. If we try to find out f of x, that will be a 9th degree equation. It will mess up a lot. So what else can we do here? This is a kind of tricky question. So we can do one thing. From f of x, we can find out f dash of x. F dash of x is simply minus 2 minus 3x square. Perfect. So this is simply minus of 2 plus 3x square. So this quantity is always positive. So this total quantity is negative. So f dash x is always negative for any value of x. Therefore, you can conclude that f of x is a decreasing function. The function will be decreasing like this. So if you consider one value x1 here and another value x2 here, so if x1 is less than x2, then what did we get? F of x1 is greater than f of x2. So this is the property of decreasing functions. All right. Now we have this particular condition. So f of 2014x less than, so f of 2014x can be written as, okay, now f 2014x can be written as f of f 2013 of x less than, similarly f 2013x can be written as f of 2012 of minus x. So if you consider this as x1 and this as x2, and this reverse is also true for, like, if x1 less than x2, this holds. If x1 greater than x2, we can write f of x1 less than f of x2. So we have something similar here. So f of x1 less than f of x2, f of x1 less than f of x2, but your x1 is this thing, x2 is this thing. So we can write f of 2013x less than, all right, we have less than here, shit, okay, we have less than here. So therefore x1 should be greater than x2. So f of 2013x greater than f of 2012 of minus x. Now again, f of x1, now this can be written as f 2013 of, okay, this can be written as f of f 2012 x greater than f of f 2011 of minus x. All right, so now this looks like f of 2000 x1 greater than f of x2. All right, f of x1 greater than f of x2, so x1 is less than x2. So from this you'll get 2012 of x less than f of 2011 of minus x. So if you keep doing this, initially for 2013 we got greater than, so for 2014 you got less than, 2013 you got greater than, 2012 you got less than. So for, if here there is an even number, you have less than. Here if there is odd number, you got greater than. Okay, so finally if you keep doing this, you get f2 of x less than f1 of minus x. All right, and f1 of x greater than, all right, f0 means no f's are there, so simply minus x. What is f1 means? That is simply f of x. So f of x is 30 minus 2x minus x cube greater than minus x. So we have to solve this. I hope you have understood. So we figured out that the function is constantly decreasing, monotonically decreasing, and these were the conditions. When there is an even number here, we have a less than condition. When there is an odd number here, we are getting greater than condition. By that logic, I wrote this, and then I wrote this. f1 of x is nothing but writing your function once. So this. So from this you can write 30, when this minus x comes to the left hand side, so that will become 30 minus x cube greater than 0. 30 minus x cube greater than 0. So x cube plus x minus 30 less than 0. All right, now this has to be less than 0. Now we have to find the number of positive integral values of x which satisfies this particular condition. All right, so how do we do that? If you observe carefully, x is equal to 3 is the root of this equation. So you can write this as x minus 3 into x square. So here you'll get plus 10. All right, and what will be the other value? So I think 3x. So minus 3x square plus 3x square. Okay, so this is the value that you will get, less than 0. So if you check the discriminant of this, discriminant will be b square, 9 minus 4ac. So this is negative, discriminant is negative, so it has no roots. So this expression is always positive. So therefore x should be less than 3. We get x less than 3 for this. If x is less than 3, then the number of positive integral values are simply 1 and 2. Okay, therefore only 2 positive integral values. Alright, so 1 and 2 are the only solutions for this. So therefore the answer is 2. Moving on, this question. Alpha beta are the roots of a1 x square plus b1 x plus c1. Beta gamma are the roots of a2 x square plus b2 x plus c1. Alpha gamma are the roots of a3 x square plus b3 x plus c3. Okay, given that alpha, beta, gamma are all greater than 0. Okay, fine. This is a very weak question that is present in this question paper. So it is, let us assume alpha is equal to beta is equal to 1. It is never said in the question that alpha, beta, gamma are distinct, and it is said in the question that they are greater than 0. So I am choosing 1. Alright. So if you try to solve this question, actually it will take at least 10 minutes, more than 10 minutes I would say. Okay. Now if alpha, beta are the roots, so the quadratic equation will be x square minus of alpha plus beta, that is 2x plus alpha beta 1. So these will be the quadratic equations. So alpha beta is 1 1, beta gamma is also 1 1, gamma alpha is also 1 1. So the three quadratic equations will be like this. So a1, a2, a3 is equal to this coefficient, which is 1. b1, b2, b3 is equal to minus 2, c1, c2, c3 equal to 1. Now sigma alpha, that is simply alpha plus beta plus gamma, so that is 3. Sigma alpha beta, that is alpha beta, beta gamma, alpha gamma, so that will also be 3 from these values. Alpha beta gamma, that will be 1. So this LHS part is 7. Now RHS, pi means product. First we have to write a1 minus b1 plus c1 by a1, a1 minus b1 plus c1 by a1, so this will be 4. Alright, similarly for a2, b2, c2, similarly for a3, b3, c3. So this is that product, and the power half. So this is 4 cube. 4 cube is 64. 64 power 1 by 2 is 8. So this value is 8. So your k is minus 1. So mod k is simply 1. You can solve this question in 1 minute if you can exploit the weakness of this question. Alright. Next. This is a differential equation. There will not be any trick to do this question. So you just have to solve this question. So let us divide the equation by x into x minus 2. So here you'll get x square by, when you divide this by x into x minus 2, you'll get x minus 2 by here only x square. So y. So now you have to find the integrating factor. Integrating factor is equal to e power integral of, so whatever this coefficient is, 2 x minus 1 by x into x minus 2. Alright. Now this is e power minus 2x minus 1 can be written as x minus 1 plus x minus 1 by x into x minus 2. So x minus 1, this minus 1, these three can be clubbed and can be written as x minus 2. Alright. Now if you split the numerator, alright, so this part will give you 1 by x minus 2 and this part will give you 1 by x. So e to the power minus integral 1 by x plus 1 by x minus 2. So e to the power minus, so this is ln x plus ln x minus 2. So that is ln x into x minus 2, e power minus ln x into x minus 2. So when you take this minus 1, it will become power minus 1. So e to the power ln of something will be whatever quantity present here. So that is 1 by x into x minus 2. Alright. So integrating factor is 1 by x into x minus 2. So once you find the integrating factor, right hand side will be integrating factor multiplied by y. So d by dx of this, and right side will be x square by simply x into x minus 2. Now integrate on both sides. On right hand side, this x and this x square will get cancelled, so you only will have x. Now integrate on both sides. When you do that, left side will be y by x into x minus 2, and right side will be, you can write this as x minus 2 plus 2. So x minus 2 by x minus 2, that is 1, integration of 1 is x, plus 2 by x minus 2, the integration of that will be 2 into ln x minus 2. So plus some arbitrary constant c. So this is the solution to this particular differential equation. So y of 3 is 9, that is given. So 9 by x is equal to 3. So 3 x minus 2 is 1 is equal to 3 plus 3 minus 2, ln 1 is 0 plus c. This is 3, this is 3. So c is equal to 0. Therefore, there is no arbitrary constant. Now y of 4 we have to find out. Y of 4, y is equal to, when you put 4, this is 4, this is 2, this is 4, plus this is 2. Alright, so y is equal to 4 2 is 8, 8 4 is 32, plus 16 ln 2. So this is ln. Alright, this is the value we got, but it is given in the question that it is equal to k ln 2 e square. Alright, so this is k ln 2 plus k ln e square. K ln 2 plus ln e square is simply 2. So this is 2k. So comparing both sides, k is equals to 16. And k by 5 is 16 by 5, whatever that is. You can simplify it and write the numerical value. Alright. So yeah, we are done with the session. If you like the content that I am making, if you like the way I have solved the questions in today's video, subscribe the channel for more such content, and do not forget to like this video and share it with your friends. You can also join my Telegram channel, the link to which is attached in the description. Do check out the other videos on the channel. There are a lot of fantastic videos that are there. Meet you in the next session.